The fastest route from where you are to where you are going exists. Google Maps will not give it to you. Not because the algorithm cannot find it, because by the time the algorithm finished finding it, the answer would already be wrong, and you would still be standing on the curb waiting for a blue line. So Google made a choice. Take a route that is almost the fastest, but get it back in under a second. The blue line you see 2 seconds after typing an address is not the result of Google searching the planet of roads. It is the result of Google having already searched weeks ago on its own time and quietly handing you the answer when you finally asked. Most people think Google Maps works like this. You type a destination. The app looks at every road between you and the place. It tries lots of paths. It picks the fastest. That story is wrong. If that was how it worked, your app would freeze for half an hour every time you searched a route across the country. To see why, look at the size of the thing Google is searching. The US road network has tens of millions of intersections and tens of millions more road segments connecting them. The whole planet is much bigger. The classic algorithm for finding shortest paths in a graph like this is called Dijkstra. Every computer science student writes it sooner or later. It is mathematically correct. It is also completely useless once the graph is the size of a country. Asking your laptop to run vanilla Dijkstra from Los Angeles to New York is asking it to consider most of the roads in America before it gives you an answer. Minutes of compute. On a phone, way longer. Nobody waits minutes for a blue line. Even smarter algorithms like A star, which guesses toward the destination instead of spreading evenly, still have to look at most of the country to be sure they picked the best route. The math does not care how clever your algorithm is when the graph has 100 million roads in it. So Google does something almost insulting in how clever it is. They cheat with time. Not your time, theirs. Here is the trick. Most of the roads on the map will never matter to your trip. The little driveway behind a school in Chicago is not part of any cross country route. The dead end street next to a forest in Texas is not part of any cross country route. There are millions of these little nothings cluttering the graph. They slow the search down and they almost never get used. So, Google does the search ahead of time for the entire continent once. In a giant batch job on their own servers with no user waiting, Google takes the road network and ranks every intersection by how important it is. Highways and ring roads at the top, city connectors below them, local streets below those, and the driveway at the bottom. Then they build shortcuts. Imagine the small road that takes you from your neighborhood onto the highway. That tiny segment might pass through 20 intersections you never notice. Stop signs, side streets, driveways, 20 real nodes in the graph. 20 things any naive algorithm has to walk through. Google replaces that whole stretch with one pretend road. One edge in the graph that says it takes exactly 4 minutes, the same total time as walking through all 20 real intersections. The 20 intersections are still there in the data, but the routing algorithm does not have to see them. It sees the shortcut. The answer it returns is identical, the work to compute it is not. Now do that for every minor road in the country. Build a shortcut over every cluster of unimportant intersections. Build shortcuts over the shortcuts. Stack them layer by layer until the most important roads sit at the top of a giant pyramid. The bottom layer still has every driveway. The top layer is just interstates and almost nothing else. What you just built has a technical name. It is called a contraction hierarchy. A German university published it about 20 years ago, and most of the routing software you have ever used is running some version of this pyramid underneath. Building this pyramid for the entire planet takes hours of compute, sometimes days. Google does it on a schedule, in the background, without you ever knowing. By the time your morning coffee is brewing, a new pyramid for your continent is already sitting on a server somewhere. Now your search comes in. One of billions Google Maps will handle today. You type New York. Your phone sends a tiny message to Google. The server does not run Dijkstra over 100 million roads. It runs two small Dijkstras on the pyramid. One search starts at your dot and climbs up the pyramid. Another search starts at New York and climbs up the pyramid from the other side. They walk toward each other through layers of shortcuts. They meet somewhere near the top, on a highway shortcut. They shake hands. The pyramid hands back a route. Each side only did half the work. Around 200 steps total, not 100 million. The whole search runs in under a millisecond. The whole search visits a fraction of 1% of the graph. The rest of the country of roads is sitting right there in memory, completely irrelevant to the answer. But there is a second problem: traffic. Traffic changes every minute. The pyramid was built last week. If a highway suddenly has an accident and goes red, the pre built shortcut is now lying. It says 4 minutes. The real answer is 20. So Google added a third phase, they call it customization. Between the giant batch pre processing and the live query, there is a fast middle step that reweights the shortcuts every few minutes using current traffic. The pyramid stays the same, only the numbers on the shortcuts change. That is how maps can route around an accident without rebuilding the entire graph. Three phases: pre-process once a week, reweight every few minutes, search in under a millisecond, three speeds, three time budgets, three problems stitched into one blue line on your screen. This trick has different names depending on who you ask. Database engineers call it an index. Web engineers call it a cache. Same idea everywhere. Pay a brutal cost once, in the dark, then charge nothing every time someone asks afterwards. Google made the call once, 20 years ago, and you have been living inside the consequences every time you tap go. If this changed how you see the app, drop a like and hit subscribe. And let me know in the comments what app I should break down next. Every like and every comment really helps a tiny channel like mine grow. Thank you so much for the support.